Welcome. Today we're diving deep into the hardware, the heavy machinery, and the really sophisticated software that's redefining global manufacturing and service industries right now. If you are looking for that definitive map of where money is actually being spent on automation, well, the International Federation of Robotics World Robotics 2025 report is pretty much the industry's crystal ball.
It really is the benchmark source.
So our mission today isn't just about reading numbers off a page. We want to pull out the most actionable, maybe surprising insights. We're aiming to cut through, the hype, the futuristic concept videos,
Right.
and focus purely on the hard data. Where's the market accelerating? Where has it maybe stalled? And what are the real drivers of growth today?
And I think if we're going to look at that hard data, we absolutely have to start with a really fundamental point, a clarification, actually.
Okay.
Before we even talk about market size or billions in installations, we've got to be clear on what the IFR counts as a robot, under the ISO standards they use for this report.
That's the essential starting line, isn't it? Because I think when most people hear robotics market, they picture, everything from ChatGPT to maybe a drone delivering their package.
Exactly.
But those big headline grabbers, they're often excluded from the specific data set, right?
Precisely. And this is, I think, the crucial aha moment for really understanding the report's scope and its magnitude. The IFR uses a very strict definition. It focuses on programmable physical machines.
Okay.
That means, a pretty long list of modern tech gets tagged not a robot for these particular statistics.
Right. So let's unpack that not a robot list then. What's out?
Okay, so out are all the purely software bots,
Yeah.
your AI, robotic process automation, RPA, generative models, all out.
Got it. Software's out.
Then remote control devices, think drones, UVs, UGVs, UUVs, they're out too. And even a lot of consumer electronics, like autonomous cars, ATMs, smart washing machines, those voice assistants you have at home. These things, while advanced, they just don't meet that definition of a continuously performing physical, industrial, or professional service manipulator or a mobile platform.
So we're really talking about tangible units here. The welding arms on an assembly line, the mobile platforms navigating warehouses, the surgical devices in hospitals. Focusing just on those categories, industrial, service, mobile, and medical. That distinction makes the investment numbers we're about to see, even more staggering, I think.
It does. It grounds the discussion in physical automation. So let's start with the anchor of the industry, factories, industrial robots. The long-term trend here is just undeniable. Global demand for factory robots has effectively doubled over the last 10 years.
Doubled in 10 years. That's not just small improvements. That's a fundamental shift in global production, isn't it?
It really is. A reconfiguration of capacity.
And what's fascinating, I find, is that even with this massive accelerating base, the growth rate itself is still robust. We're not really seeing saturation yet.
No, not at all. The operational stock, that's the total number of robots actually working in factories, has maintained continuous strong growth. Recent years clocked in at plus 11% and then plus 9%. Still very strong.
It really speaks to the ongoing need for automation. But you mentioned the composition of that growth is where the big story is.
That's right. Because for decades, the automotive industry was the giant, the heavy spender, the bedrock of factory robotics.
Sure. They practically invented it at scale.
Exactly. But the source shows the automotive sector actually experienced recent weakness. It declined by 7%.
Hold on, a 7% decline for automotive, the industry that started it all. Does that signal some kind of systemic trouble for the old guard, or is it more cyclical?
Well, it looks more like a fundamental diversification is happening, a shift in the user base.
Okay.
Because that automotive decline, it's being compensated for, and actually more than compensated for, by what the IFR calls general industries.
General industries. What falls under that umbrella?
It's broad. Everything from textiles and food processing to metals, plastics, and very importantly, electronics.
So the traditional engine of robotics automotive is maybe sputtering a bit, but this newer, broader, new economy motor is really revving up.
That's a good way to put it, yeah. These general industries are dramatically growing their market share. We're seeing growth rates in some categories as high as plus 42%.
Wow, 42%. That's the unexpected headline then. Robotics is moving beyond those huge specialized welding lines.
Right.
And into smaller, maybe more flexible manufacturing setups.
Exactly. More diverse applications.
And that idea of flexibility brings us right to a key technology niche: Collaborative robots, cobots.
Yes, cobots are really the poster children for this diversification. Their installations are showing very robust double-digit growth rates, specifically plus 12% in the latest figures.
Plus 12%. And why are they so central to this general industry boom?
Well, they're essential drivers because they're designed specifically to work safely alongside human employees. They often need less protective caging.
Right, less infrastructure.
And crucially, they're generally easier and faster to program. That makes them much more accessible, especially for small and medium enterprises, SMEs.
That's a really key point. The tech itself is lowering the barrier to entry, the skill barrier for automation.
Absolutely. Democratizing it, in a way. Okay, so now that we've seen the shift in what kinds of robots are being bought, let's look at where they're going.
The geography of it all.
Yeah. And despite this being global growth, the market remains incredibly centralized. Like if you look at new installations, a stunning 80% are happening in just the top 5 global markets. And Asia really, really dominates that picture.
Yeah, you just can't talk about global manufacturing and automation today without talking about China, can you? The data seems to show they're operating at a scale that just fundamentally changes the whole global dynamic.
Oh, the China factor cannot be overstated. It's huge. They're leading this national push for automation that basically dwarfs everyone else.
How much?
China accounts for 54% of new installations globally.
54%. More than half the world's new factory robots are going into China.
Yep, more than half. And if you look at the total operational stock across the top 10 markets, 43% of all those working robots are in China.
That velocity, the sheer speed of adoption, it's just breathtaking. Are they just importing all this tech, or is this being driven by a domestic industrial strategy? What's going on there?
Well, it's increasingly a domestic story. And that's where the geopolitical and economic implications get really interesting.
Okay.
China's growth rate, it's around plus 15%, which is basically double the global average.
Double, wow.
And this rapid adoption is being fueled more and more by the increasing influence of their domestic suppliers. They now hold a massive 57% market share within China.
57%. So they're not just the biggest buyers, they're becoming the dominant global suppliers too.
It certainly looks that way. They're building capacity incredibly fast.
And unlike, say, the established Western markets that were historically tied to automotive, you're saying the Chinese push is focused squarely on those flexible general industries we just discussed.
Yes, exactly. They're specifically targeting areas like electronics assembly, metal fabrication. The source actually cites specific growth examples in these newer market sectors of plus 31% and even plus 86%.
86%.
Yeah.
Okay. That shows a really strategic effort to automate the sectors crucial for high-volume consumer goods production.
Absolutely. It's very targeted.
Okay, now let's contrast that immense velocity in China with the more established traditional robotics economies, Japan, the US, Europe. What's the story the numbers tell there?
We see quite a bit of regional variation. Japan, real pioneer in robotics.
Right.
Their market seems to be leveling out, about 46,000 unit installations annually. They seem to be struggling a bit to find new impetus, kind of hampered by declines of their key legacy sectors. Electronics and automotive saw decreases of minus 2% and minus 4%, respectively.
Okay, so Japan's plateauing a bit. What about the U.S.?
The U.S. picture is complex. Overall installations actually declined by 9%.
9% down. Why?
Largely due to weaker performance in those same general industries that are booming elsewhere, which is interesting.
Huh?
However, the U.S. automotive industry, after some turbulence, it managed to hold steady. It's sitting at roughly plus or minus 0%. So auto is stable, but general industry dipped.
And the news out of Europe, particularly Germany, a manufacturing powerhouse, is it more cautionary there?
Yeah, Germany actually shows the largest industrial decline noted in this source material. Their traditional pillar, the automotive sector, is falling quite steeply, down a pretty jarring 25%.
25% drop in automotive installations in Germany. That suggests maybe major industrial retooling is underway, or perhaps just some temporary hesitation in that really key European manufacturing hub.
It's a significant drop, whatever the cause. Needs watching.
So if these massive established players, Japan, US, Germany, are softening or showing mixed results, who's the new star rising through the ranks? Who's kind of replicating that successful industrialization playbook using automation?
That would clearly be India. India is growing massively. It's risen to 6th place now in global factory robot installations.
6th place. And what's driving India's growth? Is it broad-based or sector-specific?
The driver there is crystal clear, and it looks highly strategic. It's their automotive industry.
Interesting. Back to auto.
Yep. Their auto sector saw a plus 16% increase in robot installations. India seems to be rapidly automating its manufacturing base, using automotive as a key lever to compete globally.
Following a proven path, but maybe leapfrogging with newer tech. Fascinating. Okay, let's pull ourselves off the factory floor for a bit now and transition into that parallel world of professional service robots, the non-factory machines.
Right, a whole different ecosystem.
And this segment seems arguably even more explosive in some ways, even if we exclude consumer robots, which, by the way, the report says grew 11% to over 20 million units. That's a lot of robot vacuums.
Yeah, a huge number. But focusing on the professional side, new professional service robots. And this includes all those autonomous mobile robots, the AMRs that zipping around warehouses. That segment grew by 9%. That accounted for about 199,000 units sold. Still strong growth.
9% is solid, but the real attention grabber, I think, reading this has to be the medical sector.
Absolutely. The medical robot sector is it's experiencing explosive growth. We saw 16,700 new units installed.
Okay.
Which translates into a dramatic growth rate of plus 91% year over year.
91%. That's not just incremental. That's a revolution happening in healthcare delivery, isn't it?
It really feels like it. The pace is incredible.
So to put that 91% medical growth in context, but what specific applications are driving that kind of massive investment? Where's the money going?
Well, it's highly specialized growth, which is interesting. We see really significant investment in surgery that was up 41%.
41% in surgical robots.
Okay. And then a truly staggering surge in rehabilitation and non-invasive therapy robots. That was up 106%.
106%. That's just incredible growth. But the number that really, truly jumps off the page is in diagnostics, right?
Yes. Diagnostics and medical laboratory analysis.
Yeah.
That segment grew by a jaw-dropping 610%.
610%. Let that sink in. Are we basically witnessing the same kind of explosive automation adoption that maybe happened with early factory automation decades ago, but it's happening now almost quietly inside clinical laboratories? What does that scale of automation even look like?
It looks like high throughput, highly precise efficiency. Laboratory robots are solving really fundamental problems there.
Like what?
They provide consistent, incredibly precise, and efficient execution of really time-consuming tasks. Things like sample preparation, analysis, often running 24/7 without fatigue or, crucially, error variation.
Consistency and throughput.
Exactly. Now, challenges remain, of course.
Yeah.
The complexity of some tasks, making materials robust enough for constant disinfection. But the value proposition for speed and precision is just overwhelming in labs.
Okay, shifting gears slightly within service robots, let's talk logistics. The source material focuses heavily on transportation, but specifically in indoor environments. So massive warehouses, fulfillment centers, maybe digitized factory floors, but not public roads yet.
That's a key distinction, yeah.
And it seems like a clear indicator of where these AMRs are seeing the most practical, profitable application right now.
For sure. The drivers here are pretty clear, too. You've got the booming e-commerce and intralogistics sectors,
right? The
persistent global worker shortage in those areas, and the need for just seamless, reliable material flow in these highly digitalized factories. Logistics robots are basically filling critical human gaps.
Makes sense. The challenge, though, it always comes back to cost, doesn't it? High upfront investment can still be a barrier, especially for smaller operations.
It definitely can be. But adoption barriers are starting to drop. Significantly, actually, thanks to new business models emerging.
Like what?
That's the key structural change the IFR highlights here, the trend of RaaS robots as a service.
RaaS, okay, explain that.
It fundamentally changes the capital expenditure model. So instead of buying, say, a $150,000 piece of equipment outright.
Which is tough for an SME.
Right. You might lease the robot for a monthly fee, or maybe even pay on a per task or per pick basis. This massively lowers those adoption barriers. It makes advanced automation much more accessible to a broader range of companies, especially SMEs.
So it shifts robotics from being a huge capital investment to more of an operating expense.
Exactly. And that's really supporting future growth, making it easier for companies to dip their toes in or scale up.
Okay, as we start to look towards the future, the report suggests the long-term global trajectory for robotics is still positive, definitely upward. But the short-term forecast seems, well, riddled with macroeconomic risk. What are the key market determinants we need to keep an eye on?
The report is optimistic long-term, but cautious short-term. Global growth, while expected to continue, is likely going to slow down temporarily.
Why the slowdown?
It's really a confluence of factors. You've got persistent geopolitical tensions, unfortunately active violent conflicts in some regions, rising trade barriers creating friction, and just generally increased uncertainty across the board. You couple that with sustained elevated labor costs in many advanced economies.
Right, which usually drives automation.
It does, but the uncertainty makes big investments riskier. So you have this market that feels necessary because of labor costs, but also fragile because of the macro environment.
Okay, a bit of push and pull there. Let's pivot then to the technological roadmap the IFR has laid out. Everyone's talking about AI. How is AI manifesting in the actual physical world of robotics, according to this report?
Well, the integration of AI is seen as absolutely paramount. The IFR is even kind of coining this new term, physical AI.
Physical AI, what does that mean exactly?
It means moving beyond just simple pre-programming, which is how most industrial robots have worked for decades. It's about allowing the robot to learn, adapt, and refine its physical movements and its interaction with the real world dynamically, based on sensor input and experience.
So smarter interaction with unpredictable environments.
Exactly. And generative AI, specifically, is seen as opening up entirely new applications by allowing robots to potentially interpret complex, unstructured environments and maybe even create novel solutions for tasks on the fly, rather than just following instructions.
Interesting. Then we have the other big headline grabbers, the humanoids. We all see the prototypes, the cool concept videos from companies like Tesla or Boston Dynamics. But what's the current reality versus the, let's face it, massive hype surrounding robots like Optimus or Atlas?
Yeah, the current reality is pretty sobering, but it's crucial for understanding the market forces right now.
Yeah.
The bottom line is there is simply no massive, large-scale deployment of these humanoids today. Not in factories, not anywhere significant yet.
So what are the manufacturers doing?
They're focused heavily on R&D, building prototypes, and maybe producing very specialized models on demand for research or niche tasks. You also have new companies building demonstrator models, mainly to, court investors and show possibilities.
The report specifically says they are far off yet. Why? What are the main hurdles?
Well, it really boils down to economics and capability. Firstly, the actual application fields for a truly multi-purpose humanoid still need to be clearly determined and, more importantly, proven in practice.
Meaning they have to show a return on investment better than a specialized machine could offer.
Precisely. And they face immense technical challenges, too, around power consumption, dexterity, the sheer cost of building them, and the fundamental ability to truly perform any task a human can in a varied environment. The source is pretty unambiguous here. The true multi-purpose humanoid remains far off yet.
So specialization is winning the race right now because specialized function offers clear, immediate ROI, whereas the generalist humanoid is still kind of looking for its killer app.
That sums it up well. Specialized machines are solving immediate problems today.
Okay. Finally, what about broader market trends? Things driven maybe by societal concerns like sustainability. Is that factoring in?
Yes, definitely. Long-term policy goals, things like moving toward carbon neutrality, are now forcing major strategic decisions for companies.
How does that connect to robotics?
Well, companies are actively reconsidering their supply chains, maybe prioritizing closeness to customers to reduce transport emissions, and automation enables that. If you automate production effectively, you can manufacture closer to your end market, making localized production economically viable again, even in high-wage countries.
Ah, interesting. Automation as an enabler for reshoring or nearshoring for sustainability reasons.
It's becoming part of that equation, yes.
And just linking back quickly to the labor shortage we mentioned, it sounds like the industry is being forced to innovate simply to keep production lines running in some cases.
Absolutely. The persistent labor shortage, especially in manufacturing and logistics, is probably the single strongest driver right now for adopting more flexible automation and exploring those new business models like RAS. It's really forcing the robotics industry to push beyond its traditional heavy manufacturing base and find new customer segments, maybe smaller companies or different industries, that historically just didn't think automation was necessary or feasible for them.
So necessity is driving innovation and market expansion. Hashtag OutTrack Outro. Okay, so we've covered a lot of ground, from factory floors in China to labs running tests 2004-7. What does this all mean for you, the listener, trying to make sense of it all? Can you give us the final synthesis of this really comprehensive report?
Yeah, I think the main takeaway is really a story of dual acceleration. On one hand, you have the industrial growth, which is becoming heavily reliant on the Asian market, particularly China, and crucially on that expansion into more flexible general manufacturing sectors away from just automotive. Right. But simultaneously, the truly stunning unit growth, those huge percentage increases, like 610%, is found in these highly specialized service robot areas. Think medical labs, internal logistics within warehouses, where the intense demand for consistent precision and 247 reliability is just completely overcoming that initial investment hurdle, especially now with models like Reyes making it easier.
That gap you highlight between the common perception of the robot revolution and the reality shown in the data, it's fascinating. The market is exploding, but maybe not with the general purpose walking machines of science fiction, not yet anyway.
Not yet.
It's exploding with these incredibly specialized functional units, the surgery bots, the warehouse AMRs, the lab analysis machines. They're less flashy, perhaps, but incredibly impactful. So the question maybe for you to mull over is this. Given the current exponential rate of specialization we see clearly in this report, will the complex, high-cost, general-purpose humanoid ever really overcome the sheer economic efficiency of these hyper-specialized, single-purpose machines on the factory floor or in the service sector? Or is the future of automation, at least for the medium term, going to be won entirely by fleets of highly efficient, segmented, single-purpose robots doing specific tasks far better or cheaper than a human or even a generalist robot ever could?
It's the big question. Specialization versus generalization.
Something to think about as you watch those lab analysis growth numbers continue to climb into the stratosphere. Thanks for joining us on this deep dive.